This is item analysis for assessment 3.6 in module 3 of CSC 343 digital forensics. Um, After all students engaged their first attempt, the average score was basically a 73%. That's a solid average. We did have some scattered questions that were considered poor or cannot calculate, largely because students all knew the answer, and so the discrimination between answers was negligible, but that's to be expected. So the difficulty ratings, there were 6 easy, 17 medium, and 2 hard questions, which is the kind of distribution we want. We don't want too many easy questions. We don't want too many hard questions. So we'll start at the bottom and work our way up with the items that posed the greatest challenge for students. We have a fill in the blank item at the very bottom, and basically it reads, according to the textbook authors, the only data collection method that does not involve the capture of an entire physical disk, logical volume, or partition is the blank method. That would be the sparse method. That's the correct answer, S-P-A-R-S-E. You may have misspelled it, so we had a case to capture anyone who put in a misspelled answer. All the other types of capture methods involve either a partition to a physical disk to image, a logical volume to image, or a partition capture. So, but the one that involves surgical capture, partial capture of a larger volume is sparse. And it's actually the more common in mid-sized to large organizations. Moving right along. This question reads, the free forensic tool WinHex provides a read-only option to protect data during acquisition. This is false. So one thing you have to be aware of is that hex editors are useful tools for assessment, for analysis. Basically, they're not the best tools for data acquisition because their operation does not allow the examination of a data file where there's a read-only feature. Now, you could have a disk that's read-only, and WinHex could work on it. But the correct answer is false. So the disk itself may be read-only, but that doesn't mean that WinHex provides that functionality. And for that reason, you have to use this tool appropriately, and you have to be aware that if you use this tool on a data file or data, evidence, digital evidence that isn't write protected, that you can create problems and modify the data if you're not careful. Paywall. So oftentimes when you have cloud-based applications and you have malicious actors at a site, this is a challenge for many forensic professionals. You have to have the same kinds of applications and resources to access the document files and data files a client's system and applications will produce. Oftentimes there's a paywall. It's a challenge that many professionals face during forensic data acquisitions, which example below accurately reflects a paywall and a cost-effective workaround for a case where online storage must be accessed and captured. Note the login and password for the online account are known and working. So free trials is basically the answer. You want to select. If you have a local version installed, you're having to pay for that, and that's not a low-cost option. So it's a cost-effective workaround. It's impossible to stock a forensic workstation, to configure a forensic workstation to have every possible version of every possible operating system and application that's out there. So that's just one thing. PayPal point of sales, that's just a bogus answer. Developers Edition, we did have one student that chose that. Bitcoin services, digital cryptocurrency, as if Bitcoin would allow you to pay for a trial version, that's just a bogus answer. So the correct answer is, you can access and use free trial versions of software if that's helpful. So that's cost effective, and it's a workaround for the paywall. You just have to make sure that you state that you were using a free version, and that needs to be a part of the record. A cane. Cane is a forensic tool distribution that was created by law enforcement professionals for law enforcement professionals. Choose the best answer statement from those listed below. The following screen appeared after a proper cane, the keyword there is proper cane forensic distribution was downloaded onto a forensic workstation. See the figure below. So now you're seeing all sorts of Windows Defender scans picking up on tools. A hash provided by those who created Cane matched the hash generated by a valid tool for the download. So we're not dealing with a corrupted version of the forensic tool distribution, the ISO, the Cane ISO. Rather, what's happening is that Windows Defender is picking up on those tools as if they were installed by hackers. So what appropriate conclusion can be drawn from this outcome? Well, we did this intentionally to work with Cane on this system. So we can't say, the Cane is infected, although that was one answer choice here. In fact, that's where a majority of students selected. The workstation is infected, the Cane website has been corrupted with malicious software. If that were true, the Cane hash and the repositories for the distribution images, when you download them and compare the hashes, they wouldn't match. So a known healthy hash result would conflict. That's not the case. The hashes do match. It was a proper download. This cannot be the answer choice. The other one that students selected in error, open source forensic tools are not used by malicious actors. That's completely false. Malicious actors often use tools more so than the good guys, more so than the forensic professionals. So one thing you need to understand is that oftentimes malicious actors know how to use these tools, and in some cases they know how to use them even better than the forensic professionals. So the correct answer is validation and verification of forensic tools is critical for each data acquisition task. It gets back to the idea that you're going to see some things on the system, but you need to know how to properly interpret those. And in this case, if you validated and verified the forensic tools properly, you're good to go. So this is not a matter of concern. This is to be expected. And Defender would pick up on it like this, and it's a false positive. Again, it's a false positive. And this is stated in your study guide and in the addendum. Which popular forensic, on to the next one. Which popular forensic tool can be downloaded and used for data acquisition, disk data acquisition, and can save to ENCASE and AFF forensic file formats? Choose the best answer statement from those listed below. Well, Geimager is open source. It's not going to save to a proprietary ENCASE format, although it may be able to save to AFF. DD is going to save a raw data image. It's not going to save a specific forensic file format. Gparted is a open source disk partition tool. It has nothing to do with forensics. That's a bogus answer. But FTK Imager Lite speaks the language of other forensic toolkits, including ENCASE, and does save to the commonly used AFF forensic file format, which was developed by an industry professional and is accepted in any court of law. It's sort of like the de facto standard for data forensic data file formats, and it's sort of like a universal language. NCase can speak it, FTK can speak it, any other toolkit that's credible can speak that language. So the answer you need is FTK Imager Lite. You actually use this tool in your solution. Okay, moving right along. We're going to run the review up through Norton disk utilities, and then we'll look at some of the multi-answer options above. Power outage next steps. You were nearly finished with your assessment and data acquisition on an active system when a power outage unexpectedly blacks out the system. You previously captured and verified the first 3 groups of volatile data in descending order and captured 2 full disk images using 2 different forensic tools. To assess the effect of the power outage and to document the integrity of your own investigation, you were directed to capture a backup copy of the Windows registry. Which tasks do you perform to accomplish this task? So which steps, I guess, would be a better way to word that. Choose the best answer statement from those listed below. So the answer that should have been selected was load regedit 32, not regedit. Then use export from the file menu. Compare this with a copy from the disk image. So you can basically look at the 2 registries. You can then import the registry and then look at it and do an item by item comparison. You can basically validate the integrity of the registry in that manner. That's one method of performing this. To use recall to recover Windows, nobody chose that answer. To use sysinternals, that's on a live system, but a number of students said extract the registry from each of the 2 disk images captured and compare them. Well, that would verify that the registry in the disk copies are correct, but that's not what the question reads. You want to make sure that the power outage on the active workstation, so you're comparing a copy on the active workstation with a backup copy. You want to make sure that if you compare both copies of both captured disk images, that's going to verify that you have 2 good captures. The goal of this, the task of this challenge is not to verify that the 2 data files are identical on either backup copy. What we want to do is compare to see if the power outage scrambled the eggs on the registry of the running system. So you have to compare you basically have to use a copy of the disk images, from the disk images, yes, but you need to work with the live system. So one of the copies for the comparison has to come from the active system, not just from the copies, if that makes sense. So your goal is to document whether or not the running system has been scrambled because of the power outage. That's significant because there could be subsequent stages. When you finish your analysis, you may have to go back and with a warrant, a legally provided warrant, you may have to get into law enforcement interests and have to go back to that system. And so what you're doing is you're making sure that system wasn't affected as opposed to the disk copies. So hopefully that will help. So the scenario is important. You have to take a look at the scenario. You always have to remember that the original artifacts in their original location, when you're finished performing your activities, one of the things you hope to be able to validate is that your own analysis, your own acquisition, your extractions and so on didn't impact the live systems. You didn't change anything on the running live systems, right? If what you're doing from your forensic activities alters the subject system, that doesn't help your credibility one bit. So hopefully, based on this scenario, I hope that explains it a little better. But that's why this answer is a better choice. Has to do with the scenario. Situational awareness is the reason that answer is different. Appropriate consideration for legacy. Okay, so for legacy encoding methods, should a forensic investigator encounter a weak and outdated method of encryption on a system being examined, what is an appropriate conclusion for such a case? Well, if something is outdated or outmoded, it could have been easily compromised, right? So data can easily be modified by others on the system, limiting the certainty of non-repudiation. So what are we saying? When you collect encrypted data, one of the benefits of encryption is something called non-repudiation, which means this data file belongs to suspect A and cannot belong to suspect B, C, or D because it's his or it's her encryption key that did the encryption, that decrypts the file, that accesses the file, that modifies the file. So encryption gives you this assurance of non-repudiation. If you have a weak and outdated method that's easily cracked by someone, it's not outside the situation. So this gets back to situational awareness, where somebody could use simple hacking tools, break open an email or a data file, modify it to frame someone, to make them look bad, and then they the suspect turns around and says, "It wasn't me, honest. I didn't do this. I didn't say this. Those aren't my words, or that's not my data. I've never seen that before." And that's within the realm of possibility. So you can't definitively link a data file to a specific user with certainty if it's a weak or outdated method. One student each chose alternate answers. The origins and internal functions of each method of encryption must be thoroughly researched. No, that doesn't help you. It's a sensible answer, but basically if it's outdated and it's weak, it's no help. And that's the main thing to consider. Simple methods of encryption are unreliable, and therefore any data encoded is invalid. That's also a premature conclusion. It all depends on the context and other details on that system. The suspect does not possess significant or advanced technical skills. The suspect may have inherited a weak or outdated method from, IT staff that are poorly trained, or their training is outdated, and they haven't migrated to newer and more effective systems. So you have to remember that the suspect is just one of a number of stakeholders in an investigation, and the important point about this matter is that normally if there's strong encryption and properly implemented encryption, you can decrypt a file, and if there's digital evidence in there, you can link that with certainty to a suspect. All bets are off if it's outdated or outmoded. I hope that explains things sufficiently for that item. Here's another encryption-related item that was a challenge for students. A highly skilled hacker has corrupted the use of the custodian key for an Active Directory domain that is used to decrypt and view EFS encrypted files and directories. That means the privileged account management for this organization was weak and somebody got a hold of it, it means, so by default in Active Directory, the domain administrators are encryption custodians for all the keys for all the users that use EFS. EFS is the built-in file and directory encryption, not whole disk encryption. It's not BitLocker, but it's encryption file system. It's the checkbox when you go into properties. You can encrypt something based on your login. Which specialty tool should a forensic investigator use to decrypt and view encrypted files and directories in this case? Choose the best answer from those listed below. Well, if it turns out that you're dealing with Active Directory, LCOMSoft Forensic Disk Decryptor is basically a tool that is designed to deal with scenarios like that. This is plainly stated in your addendum. So if you search for the details of this question in your addendum, it basically calls out this product specifically. 2 students chose the root certificate of an Active Directory Certificate Services PKI server. That's not going to help you decrypt everything, and PKI is often used in Active Directory scenarios through something called certificate services, but the root certificate doesn't have to do with encryption on the EFS level. So PKI has to do with public asymmetric encryption keys, public and private. EFS involves a symmetric key that's used to encrypt. And those keys are managed centrally through Active Directory. Other students chose this one. Type the command manage BDE unlock X recovery password, and then enter the key. That's just a bogus answer. I completely made that up and pulled that out of my backside and typed in a command that I thought would look like it's valid, but if you enter this command in any administrative command prompt, you're going to get this error message that says command not found. I don't know what this is. So that's just a bogus answer. Which file system? So, which file system? A data acquisition of a boot partition on a physical disk returns an error that states master file table not found. Okay, so older legacy file systems use an MFT. Choose the best answer from those listed below that relate which file system and OS is used for this boot partition. So NTFS and Windows is what's used. NTFS is not associated with Linux. EXT is not associated with Windows. EXT4 is associated with Linux. So EXT4 and Linux are associated. NTFS and Windows are associated. FAT32 is an older version of Windows. And the older legacy version does have a master file table, but especially when you're dealing with dynamic disks, you're dealing with a different file system structure with the NTFS file system. And if it was FAT32, you wouldn't have this error. So that's why this answer is not a good choice. If that's not showing up, it means a newer file system associated with Windows. The new file system associated with Windows is NTFS. So that's one thing you have to be aware of when you're working with data acquisition or the different types and flavors of file systems. We'll actually finish these 3 instead of stopping here. Norton disk utilities can be used to recover and acquire hard disk and floppy disk data for a legacy system using Microsoft MS-DOS 622. That is true. Norton disk utilities was one of the earliest data recovery utilities. It is effective. It runs from the DOS prompt before they ever had Windows. So that is a true statement. It's just a terribly old tool. And floppy disk data is terribly old as well. So if you're dealing with a very old computer system and you don't know how to get data off of, recover data from floppy disks. Norton disk utility is your answer. Static acquisition. So we have live acquisition and static acquisition. Those are the two main components of the acquisition phase. Static usually involves capture of data stores when the system is powered off. Live acquisition is on a running system. Which statement regarding static acquisitions is true? Choose the best answer from those presented. Physical evidence has been previously collected. Only digital evidence is collected for a static acquisition. That would be a correct answer because during the live acquisition, you're using a digital camera to capture, okay, what cables are plugged into the machine? Are there any thumb drives inserted? What's running on the screen? All that kind of stuff. Those are physical, that's basically physical evidence. So that would happen, physical evidence would be previously collected during the live acquisition phase, so that's a true statement. The other two false statements that were chosen by students: digital evidence has been previously completed. No. Digital evidence has been previously completed. What about digital evidence has been that's a vague statement. Only physical evidence is collected for a static acquisition. No, that's not true. Digital evidence is collected during a static acquisition. It's usually a data store. It's usually from a data store, and it's usually powered off. All right. The state of an active system is captured. That's live acquisition. Okay. So that would not be associated with static acquisitions, including the content of CPU registers, cache memory. That's all live acquisition, not static. So this would be a great answer if the question read, which statement regarding live acquisitions is true? This would be the choice you'd want to select. Okay, this is our last question for review. Disk data storage. There are 3 requirements for successful storage of disk data. Choose the best statement from those listed below that reflect the 3 requirements. Now, of the 3 answers, this one is correct. Digital content inside the file is part of the interest for acquisition, for successful. So when you're trying to capture a successful digital evidence from a disk store, you need the digital content inside the file. You need the metadata of the file itself, things like who created it, when was it last modified and by whom, what are the dimensions of the graphics file. Those are all metadata. So those are things that are, those are elements of interest that are captured along with the file itself. And of course there are file system attributes like where the file is stored, the permissions assigned to the file, and the ownership. So you need metadata and you need file system attributes. Specifically, is it read-only? Is it executable? Is the archive bit set? Those are things that are important. So there are 3 components for disk data. It's in your study guide, listed 1, 2, 3, and it talks about each of those. And this is the only answer that comes close. File system privileges, permissions, and inheritance for the system environment. Yeah, I used this term inheritance. I borrowed that from an operating systems course. But whether or not inheritance is turned on or off is not always relevant when it comes to disk capture. System privileges and permissions, that's only one part. That's only one of 3 components you're interested in. The master boot record, file handles, and metadata. File handles would have to do with live file access processes, but how that's working in the operating system is not something you'd be interested in capturing on a regular basis. You would work with file handles if you were using sysinternals on a live system for a technical, private, internal, informal investigation you were conducting with IT professionals. Metadata is one of those things, but master boot record, that's not something that is always a requirement of successful capture of disk data, because sometimes you have a sparse capture. You don't get the master boot record in the volume, the disk volume, and that's okay. So master boot record is not a requirement. Again, it's in your study guide. Let's look at some of the ordering, and I guess everybody got the ordering correct. That's awesome. So max credit for that. And we could not calculate. Everyone got this one correct. Here's an ordering question that was not all correct, and a multiple answer where there wasn't full credit. And there's a couple of multiple choice that were worth more. This one here, which network forensic tool? All right, so let's take this question. Choose the best answer statements from those listed below. Older physical hard drives from a data acquisition include significant HPA disk memory. In this case, it is suspected that hackers with advanced technical skills have hidden malicious code to ensure the HPA. That's the hidden partition. So when you're looking at a disk, and you go into disk management, this is the viewable partition, but there are hidden partition areas like system and recovery partitions. That's what HPA refers to. So in this case, it is suspected that hackers with advanced technical skills have hidden malicious code to ensure the HPA is part of the capture. Which tools should be avoided? So actually, Linux DD, I'm going to take another look at this. This one might be a valid answer. I'll take another look at it. But Linux DCFLDD, basically I think when it comes to HPA disk memory, both Access Data FTK Imager and Encase are appropriate tools. So selecting these would not be, the question asks which tools should be avoided. So these are two good tools to use. The Linux DD tools are whole disk. You're grabbing an entire partition, but you're not necessarily grabbing the HPA area. So either version of DD would not be appropriate if you're grabbing, they're blunt tools, and it's basically an all or nothing kind of thing. But in this case, you want to capture the HPA disk images separately, and that's because you want to see what the hackers did with it. So these two tools would not be a proper choice given this scenario. So just remember, FTK Imager and Encase both can work with HPA. But DD and the other version of DD do not. Let's look at this ordering. So the correct order, arrange the correct order of steps taken in Kali that is running in forensic mode to analyze data. So this is what you performed for your solution. If you basically retrace the steps of the solution, then you'll have the correct order. We had a student that selected basically selected other options, but the first step is to open a terminal and provide the password for SU for elevated privileges showing a pound prompt. So when it comes to having proper rights to execute certain commands, you want to make sure that you have the appropriate privileges, that means you have to have root level privileges. So that's step 1. Step 2 is to create a copy and verify the specified disk image using Geiger, the temp directory, and hash values. So you're going to perform this step second. The third step is execute the autopsy command and paste the link shown into a web browser to create a new case. So whenever you're using these forensic tools, the first step after disk capture, when you're getting to the point where you want to start analyzing, or you want to even before that, when you want to do some disk carving with extraction, you're going to have to create a case. So when you start using other tools, tool suites, you often have to create a case. You're going to add a host, add an image using the copy option, verify the hash, and select the C mount. That's what you do after you've created a new case. That's loading the image in there is what you're doing. Fourth step. The last step is select file analysis. Browse selected files, directories, metadata, extract selected artifacts, noting the hash. So as you perform that last step, using Kali and autopsy, what happens is that your final step is to run the analysis. So that's the last item you choose. So that's the correct order of process we followed in the solution. Same exact steps we followed in the solution. Okay. Last two we'll check here, and then we'll conclude our item analysis. What is a common outcome of initial data analysis results? Well, when you initially analyze your data, oftentimes you have to circle back, and then you realize, oh, there's some more answers we don't have any definition for. So you have to expand or extend the original scope. And in cases where that's a negative thing and it wasn't planned for, that's called scope creep, right? So new discoveries lead to the new acquisition and analysis outside the original investigation scope. That is a very common outcome of initial data analysis. So you go in there, you have an original interest, you perform the acquisition and analysis for that original interest, and then lo and behold, oh my gosh, we got to go back in and do some more. Or we don't have definitive answers. Was a crime committed? It may or may not have happened. Was something done with intent? So you can make the proper human resources decision. You may or may not have those answers because of the limits of the original scope. The rest of these answers are all framed in a similar manner, but they're not correct. Hashing algorithm errors caused by changes from active data analysis tools? No, that's not the conclusion you can draw. If your hashes match, that doesn't mean you have algorithm errors. The hashes match. The engagement of law enforcement is as new discoveries unveil malicious actions by criminals? No, sometimes you don't have to involve law enforcement, but you reach a conclusion that you may be making some personnel decisions about firing or punishment, right? Reprimands, demotion, restrictions, whatever. The need to repeat procedures when forensic investigators forget to validate tools before analysis. Hopefully that's not a common. If that's a common outcome, we're not doing things properly in the first place. So the question assumes that we've done something correct. What is the common outcome of initial data analysis results? It's not that people are so goofy they don't validate and verify. That's not a common outcome. That's an undesirable outcome, and the professional career prospects for someone who has that issue are typically short-lived. But in any case, that's not a common outcome. Okay, that concludes our item analysis for our final, the first attempt of our final assessment. Good luck on your retake. If you have any other questions or concerns, please feel free to check in with me. Oh, I'm seeing here there's one more question we might take a look at. Which network forensic tool? You were hired to conduct a digital forensic. Evidently not everybody chose this correctly. There was one person. That quickly reveals the unexpected presence of skilled hackers operating remotely in the environment. Remotely is the key. So you have remote hackers, they're skilled hackers, and they're active in the environment. Which network tool is best suited to conduct an initial assessment of how exposed the local network environment may be to such exploits? Well, Nmap helps you look at what's going on with your clients in the network. It's unobtrusive, it's a low impact, it's not as serious as a vulnerability tool assessment, which can load the environment down terribly. Wireshark is not a good use at first because you usually use Wireshark to focus on specific subjects, so it's the Nmap that helps you quickly reveal where your focus needs to be. And then Wireshark is what's used afterwards. Geimager is used for disk image collection. It's not a network analysis tool. And nobody chose Autopsy because they know that Autopsy is used for analysis, but not network analysis. So Nmap is the correct one. Geimager is a disk acquisition tool. It's not used for networks. And there you have it. Okay, this concludes our item analysis. Good luck on your final attempt of the assessment and your final exam.